I'm not going to talk about the test itself and how it's performed. I'm going to cover the changes that have been made from the 2012 to the 2019 edition and look at the changes that are coming. The document is currently in revision cycle, and the first draft ballot is open right now for the committee. We still have a long ways to go till we get to the next edition, but we'll look at where we're at with the first draft, and then we'll look a little bit at the annex for the engineering extensions. So a brief history. This whole test came about as a result of the Federal Trade Commission's complaint to the plastics industry and some research work that was done in the results that were published in 1980. Some of the things that were issues were terms used like non-burning and self-extinguishing. Those are taboo in our world. We don't use those terms any longer. A result of the research committee's work was the development of the full-scale fire test, which was published in UBC 17-6. That later became 26-4, which evolved into the apparatus as we know it now, and UBC 26-9, and then NFPA 85 picked that up and has gone through several revisions since that time. So the 17-6 first appeared in the 1988 edition of the building code. It was a 26-foot tall apparatus, two-story structure, 12-foot tall rooms. It was outside, and it used a wood crib as a fuel source. Later, when the code was reorganized, they renumbered it to 26-4. It basically stayed the same. There were some problems with the test. Whether burning a wood crib as a fuel source proved to be a little bit unreliable. Timing with the construction, trying to get it in when weather was right, and costs. And so the apparatus was reconsidered, and a smaller scale apparatus was developed, and that version was published in 26-9 in 1997. It was reduced scale, 15 foot, 8 inches tall, 7 foot floor to ceiling heights of the rooms. Able to move the apparatus indoors, so weather was less of an issue, and use gas as a fuel, so the repeatability and reproducibility were much improved. And then Beidel did a lot of work in the development of the apparatus and demonstrated, strong correlation to the 26-4 and its previous version of the 17-6. In 1998, NFPA picked up the standard because the 4 building codes in America merged into one, and the test standard itself was no longer in a consensus cycle. So NFPA picked it up basically word for word and published it as 285. The 2000 edition of the IBC first incorporated NFPA 285 in Chapter 26 for foam plastics. And the current edition is the 2019 edition. So in 2012 to the 2019, there was a change in the title, and non-load bearing was struck from the title. So it read the same, less the non-load bearing, because the possibility of having a load bearing wall was recognized. There was some changes throughout the document to clean up the non-load bearing. Also, there were some issues. Now we're seeing high-rise structures made with wood. And the way the scope and purpose read, it looked like it applied only to non-combustible construction. And so in some cases, the standard was being misused by saying that it didn't apply because it was a combustible construction. And then there were some cases where we weren't quite sure if it was applicable for wood or not. And so the committee decided it could be applicable for wood and cleaned up the language so that it could be used for wood construction. Definitions were changed to add 2 of the ASTM standards, one for non-combustible materials and one for limited combustible materials. There was a change in the burner height, and this has created a little bit of confusion in the industry because it appears like it might be a mistake. It went from 2.5 foot plus or minus 1 inch, 2.5 foot plus or minus 1 foot. The reason is the language says that it's above the floor surface of the test facility. So there are different apparatuses in North America, and the curb slab that the apparatus is built on could be 6 inches, it could be 12 inches, it could be something different. Since the burner references off the facility floor, that allows a tolerance for various curb thicknesses that's greater than 1 inch. The burner position relative to the window and the test wall remains the same, so it has no technical effect on the test. It's just to help facilities comply with the letter of the requirement. So some changes with the description of the test specimen. The term added representative actual field construction, and then an allowance for wood studs was added. And then the most significant technical change in the document occurred relative to the joints. On the left side here is the 2012 edition language, one sentence. It's now broken up into quite a few. What you see on the right is half the language for horizontal joints. The vertical joints is on the next slide. So previously it said that if your system had joints, you should test it with joints, but it didn't say where or how. If joints were a problem for a system, they could put the joints outside of the fire plume and have an easier time passing the test. And still say they had joints in the system. So now the language says that if you have joints, then you have to have a horizontal joint within 1 foot to 3 foot above the window. It has to go full width of the wall. There are some exceptions. If it's an exterior insulation finish system, the EPS foam with the stucco coating on it, you don't have to include the joints. Or if it's a minimum 3/4 inch thick stucco veneer, you don't have to include joints. And then a kind of catch-all, if the actual design of the wall system doesn't have any joints, then you don't have to test it with the horizontal joint. And then for the vertical joints, you put one full height above the window center line, plus or minus 12 inches. And same exceptions apply for exterior insulation systems, exterior insulation finish systems. The 3/4 inch stucco veneer. And then here, again, if your wall system doesn't have vertical joints, then you don't have to invent one just for the test. And then one other item here is that the joint is to be as it is an actual design. You don't want to test the wall and put a non-exterior intumescent caulk in the joint to help you pass the test, only to not use that in the field. You have to test it as it will be used in the field. The language cleans that up. There was some language added that if you're testing a wall that is for an ad hoc purpose, say you're trying out a new kind of construction that's being built, then you can do it, as per that construction. And it seems intuitive, but sometimes it needs to be stated. And then window headers, there was a significant change there, a lot more words added. There's 2 paths. One is a prescriptive path and one is a performance path. The prescriptive path is you use a 1 millimeter thick aluminum sheet. There's no drip edge put on the front. It comes flush to the front surface. Can have a bend in the interior side. And then no fire blocking or other blocking around the window header. That gives you the most flexibility for different window header designs and systems. If the window header design and blocking is part of your wall system, you can test that, but that has to be detailed and documented in the report. And then you'd have the least amount of flexibility with that type of system. You'd have to demonstrate any changes would be more robust than what was tested. Change in the calibration procedure. Anybody that's ever been a part of a 285 calibration will understand this. There's a vast array of temperatures and 3 heat fluxes that you have to line up. And it's an iterative process. You run a test, you make adjustments, you run a test, you make adjustments, and inevitably you never get all of them to line up. So you try to make it so it's conservative, and those that are not in alignment are high. which it sometimes made it out of tolerance and theoretically didn't comply with the requirements of the standard. So the upper end was opened up to allow 20% above on the temperatures, just so that the labs could get the calibration done and be in compliance. If the labs are doing it correctly, nothing will have changed, other than all their temperatures will then be in compliance with the standard, but they won't be any higher theoretically. And then the report requirement, well, within the procedures, they took out the 10-minute post-test observation. That was somewhat meaningless. There was no criteria. The lab just had to sit there and watch the wall burn for 10 minutes, but there was no pass-fail criteria. They took that out as a requirement and made it optional in the annex. Should the test sponsor want to do the 10-minute post-test observation, they can. But the lab doesn't have to do it if the sponsor doesn't want to. The requirement for the window opening header, detailing that, and then you now have to report the calibration as part of the test report. Prior edition, you didn't have to report your calibration numbers. So in summary, the revision allowed for the possibility of load bearing. It wasn't specific to combustibles and non-combustible construction. It does not exclude wood stud framing. It put in the requirements for the joints, tightened up the window header details and the requirements for that. And there were some other changes, such as revisions to NFPA boilerplate language, editorial edits for the year revisions and the reference standards. So the next cycle, like I said earlier, we're in the first draft revision. It's currently, the ballot's open for the committee. It still has to go through a second draft revision, and then go through the NITMAM process. Relatively minor changes, just a couple technical. So the administrative ones are typical with all the revisions, updating any changes to reference standard titles, years, and edition. There was a correction in a thermocouple numbering error in section 10.2.2, subparagraph 2, subparagraph B. Just the TC numbering was off. In section 1.1 and 1.2, the term "and panels used as components of curtain wall assemblies" was struck. Sections in chapter 4 were moved to chapter 7 in the calibration. It's really where they belonged. Nothing changed other than they just got relocated, so I'm not highlighting the text here. 2 sections were added in section 5, and this has to do with how do you treat the edges of the wall. Lab practice has been to seal the edges of the wall, either tape them shut or flash them shut. But it wasn't written in the standard, and so it needed to be. So it adds that how to deal with the edges of the wall. And then one of the technical changes was some tests have happened where there's been fins added at joints to try to push the flame off the wall or otherwise redirect the flame. The language says that you shouldn't do that unless that's part of your system. And then if it is part of your system, you have to report that. That was added in the report section. And then a clause was added at the end of 5716 that states unless the construction is not intended to incorporate studs, because it recognizes there could be some base walls that are concrete panels and not necessarily stud walls. And then the addition of the annex for the guide on engineering extensions. And that's probably going to be the most significant change because it provides guidance on extending the data. And these are the topics that it covers. So we have base wall construction, whether it's steel studs, wood studs, gypsum, alternatives such as concrete and masonry units. And then what about cavity insulation, from spray foam to mineral wool to fiberglass? 4-line fire stops, different types of exterior sheathing, water resistant barriers, over exterior sheathing, air gaps, what's allowable air gaps, what should be tested, exterior insulation where it's applied outside the base wall, exterior weather resistant barrier, drainage mats, exterior cladding, attachment systems, and window perimeter header jams, sills, and the flashing for those. So with that, completes my presentation. I believe we'll have time for questions at the end of the session, if I'm correct.
Yeah, that's perfect, Barry. Many thanks for that.